This is a solution video for Chemistry Paper 1, Set 1. You can download the soft copy from the description below if you want to practice before checking the answers. And of course, you can skip to the end of the video for the answer straight away. Alright, let's start with the first question. Diagram 1, 2 and 3 shows the particles of three substances at room temperature pressure. Okay, so this one, question 1, the topic will be under solid, liquid and gases. Okay, so which of the following substances are correctly represented by the corresponding diagrams? So let's look at the diagram. So this one definitely will be your gas, as well the particles are far apart from each other. And this diagram 2, the particles are disorderly arranged, but they are still closely packed, so this one will be liquid. And then this one, orderly arranged in a closely packed arrangement, so this will be a solid. Okay, so for argon is a natural gas, so it will be gaseous. Mercury is a liquid metal at room temperature, so it's liquid. Dry ice obviously will be your solid, so it's a solid CO2, dry ice. Okay, so but it's in the solid state. Ethane is a gaseous state. Okay, sodium chloride should be a solid state, okay, under room temperature pressure. So important is room temperature pressure. Then next, mercury is liquid again. Ethanol should be a liquid. Hydrogen chloride, take note, this is not hydrochloric acid. So hydrogen chloride is actually exists in a gaseous state, okay, they exist in molecules. So copper is a metal, so it's a solid. And water obviously is a liquid state. And helium is a gas, helium gas, your weather balloons. And then zinc is your solid. So the only one that makes sense is A. Alright. Question 2. The following setup shows how the relative rate of diffusion, okay, of X and Y can be determined. So this is under rate of diffusion. Okay. So under diffusion, there are two factors that will affect your rate of diffusion. The first one is the molecular size, okay, of the gases, and the other one will be your temperature as well. Okay, the higher the temperature, the faster the rate of diffusion. Okay, the MR, as the MR increases, so it become heavier. Okay, so the rate of diffusion will be lower. Okay, so which pair of substance X and Y could be if the water level at X increases? Okay, so this is the keyword. So Z increases, so here you have to increase, so means here has to go down. So in other words means what? Gas X is outside the cylinder, okay, the beaker. Y will be inside, so it means what? In order for the water level at this part, the left armor, to decrease, right, so your gas X must enter much faster than what Y is coming out. Okay, so X must go in faster. Okay, so another means what? X must be lighter. Okay, and this should be heavier. So coming back, so you are looking for X that must have a smaller MR, and then Y must have a bigger MR. So for this question, right, you have to calculate the MR for all the options. Okay, so let's start with ethane. It will be C2H6, this CO, CH4, N2, CO2, O2, N is just Ne, and argon is just Ar. So if you look at the periodic table, so take note, you have to use the number at the bottom of the chemical symbol. So argon, it will be 40. Neon, it will be 20. Oxygen is 16 times 2 is 32. Then this 44. This one is 24 plus 6 is 30. Then this 28, 16, and 14 times 2 is 28. So take note, you are looking for X, which is the lighter one. Okay, so X must be lighter. 44 compared to 28, this is too heavy, cannot. So the only one that makes sense is B. Okay, 20 is lighter than 28, so answer is B. Alright, moving on. Question 4. The three main components of liquid air are nitrogen, oxygen, and argon. So they have their respective boiling points here. So liquid air can be separated into three main components by fractional distillation. Okay, so the graph shows the temperature of a liquid air mixture as heated. So first thing first, in section P of the graph, this is this part here. The mixture remaining consists of, okay, so take note, this one is fractional distillation. So basically, it will undergo what? From liquid to gas. Okay, so whichever have a lower boiling point, he will distill off first. So if you go back to your boiling points here, okay, so which one will have the lowest boiling point? Nitrogen, minus 196. So nitrogen will be the first one to boil off, followed by argon, lastly oxygen. Okay, so if you see carefully, there are three plateau. Let me use a different color. This is the first one. This is the second one. And this is the third one. All right. So when you reach M, which will be coming out first? Your N2. Okay. He will boil off. Okay. Followed by stage 2, it will be argon. Then lastly, at Q, it will be oxygen. So coming back in section P here, section P, the mixture remaining consists of what? At P. So means nitrogen and argon already gone. Okay, so only left with oxygen gas. So answer is D. Alright. Okay, so this one it should be under separation techniques. Next one. Question 5. So this one look you should know is under chromatography. Okay, is obtained from the analysis of a dye mixture. So 4 measurements are shown here. So you have one is for the red spot, this for the purple, then blue, then solvent front. So RF value, okay, RF value, and then for the most soluble dye. So most soluble dye means it will travel the furthest distance. Okay, furthest distance obviously will be your blue dye here. So RF value, the formula. Okay, distance travel by solute over distance travel by your solvent, which usually will be your water. So in this case, what's the distance traveled by the solute, which is the blue dye, which is from here to here? Okay, it will be 8. Divided by solvent. Solvent is from here to the starting point, which is 10 cm. So answer is just 0.8. Okay, so answer will be B. Question 6. Element Y burns in air to form an acidic gas which decolorize potassium manganate. So your potassium manganate, okay, so it's your famous oxidizing agent, okay, OA. So you'll turn from purple to colorless. Okay, so if this element Y burn in air, so means it react with oxygen gas to produce an acidic gas. Acidic gas basically is a what? It's a non-metal oxide. Okay, and it must produce a what? A reducing agent. Okay, because only a reducing agent will cause your oxidizing agent to turn from purple to colorless. Okay, so I repeat again. So meaning element Y is actually a non-metal. You are looking for a non-metal, and it must give you a acidic gas, non-metal. Okay, so magnesium is a metal, so it's out. Okay, and carbon, when you burn carbon, you might form CO or CO2. Nitrogen is NO or NO2. Sulfur is SO2, okay, or even SO3. All right. So if you do by elimination, what is your answer? Question 7. Solid X was heated until it completely melted. Okay, and then which of the following are true about particle X? So if you zoom in, so take note, it started at solid state. So this is a solid plus liquid, and this liquid. So let's look at the option option 1, they are closer to each other at stage RS. RS is a liquid state, and then PQ is a solid state. So in liquid state, they are closer. That's not true. They are actually further apart. Statement 2, the forces of attraction are stronger in stage P, solid, than in liquid. That is true. The arrangement is more orderly in RS, more orderly in liquid than solid. That is not true. Their total energy content at stage QR, meaning solid plus liquid, is lower than that in liquid state. Okay, that is correct. By elimination, you can tell as well, because only statement 2 is correct and statement 3 are wrong. So statement 4 must be correct as well. So option is A. Okay, so this question is under solid, liquid, gases. Next one. Which particle contains the same number of neutrons and electrons? So this will be under your atomic structure. So the best way to do this type of question is to just list down the number of proton, neutron, electrons for all the 4 options. Okay, so calcium will be 20 proton. So you minus away 40 minus 20, you get the neutrons, which is 20 as well. Electrons will be 18 because it give away 2 electrons, so it's 18 electrons left. So it is 12 proton, 12 neutron, and this is only 10 electron. And then this one will be 9 proton and then 10 neutron, and he take in 1 more electron, so it's 10 electron. And for last one, sulfide, 16 proton, 16 neutron. He take in 2 more electrons, so the total will be 18 electron. So you want the same number of neutron and electron. So the only answer is this one. Okay, so answer is C. Question 9. The carbon has 3 isotopes: carbon 12, carbon 13, and carbon 14. Which of the following about carbon 14 is wrong? Okay, so it's found in carbon dioxide in the atmosphere. Yes, it should be true. There's not a lot, but it's still true. It reacts with limited oxygen to form carbon monoxide. Yes, because this is under incomplete combustion. If it's complete combustion, you will form CO2. Okay, but if it's incomplete, you will form CO. Okay, that's true. So it has different electronic configuration. That is definitely wrong. Okay, different. Because although they are isotope, the number of electrons is the same. Same electrons. So their electronic configuration will be the same as well. D, it will be true as well. Because if you see carefully, carbon usually has 6 protons. So if you 12 minus 6, you have 6 neutron for this. Then there's 7 neutron. Carbon 14 will have 8 neutrons. So it will have the greatest number, so it's true. So the only one that is wrong is option C. Moving on, question 10. So which of the following is an element? Okay, take note, it's an element. It's made out of covalent molecules. So covalent is non-metal bonding with non-metal. Okay, so this will be under your chemical bonding. So take note, it's an element. It's an element. So ice is a compound, definitely is out. And sand is silicon dioxide. It's out as well. Ice, for those that are not sure, is H2O. Okay, just in the solid state. Iodine is possible, is I2, and then argon is Ar. But another keyword is what? It must be molecule. Okay, argon is actually exists in atoms, so it's out. So only iodine is existing in molecules. So answer will be B. Okay. Question 11. Element X and Y, they are in group 1. So this is your alkali metals. So this question is under periodic table. So X and Y are added separately into cold water. X is first discovered to sink to the bottom, okay, whereas Y will actually float. So from this we can tell, as you go down the group, down, group 1, the density actually increases. So if say x will sink, so x will actually be the bottom, and then y will be at somewhere higher than x. So for example, y might be let me see, can be like sodium, and then x might be rubidium. Okay, so sodium is very light, so it will float on water, whereas x is for example like rubidium is denser, so it will sink to the bottom. Okay, so coming back to the question, which of the following statement about x and y are correct? Okay, atom y has more proton. Atom y means sodium has more proton. It's wrong. It has less proton. Effervescence is observed immediately when y is added to cold water. I think this should be true. Immediately, actually both are immediately. So okay, for now I'll just take it as true. We see how it goes. Okay. Statement 3, x has a lower boiling point than y. So x, for example, is rubidium. Y will be sodium. So x has a lower boiling point. That is true as well, because down the group, your boiling point actually decreases down the group. Okay, so it's true. So which one is correct? 2 and 3. So answer is C. Okay. Next one, question 12. Which compound contains the highest percentage of sulfur by mass? So this is under your mole concept. So this one you just have to calculate the MR, okay? Calculate by MR. So if you look at the periodic table, so you have to do one by one, there's no way out, okay? So H2SO4, so this will be 32 over 2 plus 32 plus 48. And this one will be 32, okay, because there's only one sulfur, and then potassium is 39. Alright, C will be 2 times 32, 2 sulfur, over lead, it should be 207. So you have to check your periodic table. And last one will be sulfur dioxide, which is 32 over 32 plus 2 oxygen is 32. Alright, so just press your calculator one by one. I think the answer should be D. Yep. Okay, so this is like 0.5, which I believe should be the most likely the highest. So if you want, you can try for A, you can try what is this, B, C, and D. Okay, so you can times by 100 for everyone, but this one you can just do in ratio, is fine. Okay, so answer will be D. Question 13 will be under mole as well. Okay, so in the extraction of iron, hematite is added. So hematite contains iron 3 oxide, which is this one. All right, react with CO, give you iron and CO2. Okay, so a 10 kg sample, so react with excess CO, give you 4.7 kg of iron. So this is 4.7 kg. So what's the percentage purity of iron 3 oxide? Okay, so you're looking for the mass of this. So you can use the 3-step template. Okay, so the first point is what? Iron is a starting point. Okay, so if you look at my notes, you will know how to use your 3-step template. Okay, so first you have to find your iron. That's your starting point. So mole of iron equals to mass over AR. Alright, so iron is 4.7 times 10 to the power of 3. So I have to change to grammar. Iron will be 56. Okay, see what you get. Okay, just give me a moment. Alright, so if you key this in your calculator, you can just leave it in 3SF, is good enough. So you get 83.9 mole. Next, you have to do your mole ratio. Iron dot to your ending point, which is Fe 203. Okay, so the ratio is 2:2. 1. So for 2 units is 83.9. 1 unit, you just divide by 2, you should get 42.0. Okay, 3SF. Then lastly, you want to find the mass. So it's mole of Fe2O3 equals to mass over mR. So you get the mole equals to mass, you're looking for mass, mR of iron 2 oxides, 2 times 56 plus 3 times 16. Alright. Times 42. So you get 6720 grams. About 6.72 kg. Okay, not yet done. So this is the actual mass of iron 3 oxide in hematite. So if you want to find the percentage purity, so percentage will be 6.72 divided by the grand original, which is this 10 kg times 100%. So it's about 67.2%. Okay, so the nearest answer will be D. Okay, so this is your 3-step template. Question 14. So analysis of molecule X contains shows that it contains 59% of carbon, 10% of oxygen, and 31% of oxygen. So from here you can figure out your empirical formula. So from empirical formula, you want to determine your molecular formula. You actually need the MR. You need the molecular mass of your molecular formula. Okay. So let's look at one by one. Atomic number. Yes, this is the one. Okay. You need the relative molecular mass of X. Okay, which is this one. Okay, so you need D. Answer will be D. To reduce atmospheric pollution, the waste gases from a coal burning power station, okay, so this is under atmosphere, under your air or atmosphere topic, okay, pass through a powdered calcium carbonate. So this is your fuel gas desulfurization. Okay, so still remember this one, you're supposed to remove acidic gases, any acidic gases, for example, yeah, any acidic gases like non-metal gases. So this is neutral, this is acidic, and this is acidic, and this is acidic. Okay, all these are acidic oxides. So which waste gas will not be removed? Will not be removed. So answer is only A. Okay, that's all. So question 16, which of the following can actually increase the yield of ammonia? So in your Haber process, so this is ammonia topic. So first you have to write down your equation for Haber process, which is N2 plus H2. Take note it's a reversible reaction. And you balance the equation. So it's 1, 3, 2. So which of the following will actually increase the yield of ammonia? So just do by elimination. If you use the equal volume, it actually doesn't work because the ratio is what? 1:3. And then if you use platinum, platinum is not a catalyst. It should be iron. Alright, so it's wrong as well. And next is if you increase the pressure to 450 or increase the temperature to 1000. For the Haber process graph, let's say this is the temperature, this one. So let's say this 350 degrees Celsius, this 450 degrees Celsius. Okay, so on and so forth. This is actually pressure, and this is your yield. So as temperature increases, your yield actually decreases. Alright, so higher temperature is not advisable. So the only one that makes sense is what? Increasing the pressure to 450 atmosphere. Okay, so answer will be A. Next one, question 17. Which of the following pairs of solution will show no visible change when mixed? So this should be under either sorts or QA. Alright, so take note, no visible change means there's no PPT most likely, or no bubbles, no PPT, or no bubbles, or no gas. Alright, so let's look at the first one. First thing first, B, if you exchange partner writing the products, right, you'll get lead 2 sulfate, okay? So PbSO4 is a PPT, okay? So this one definitely you'll see something, so it's out. Sodium carbonate and magnesium nitrate. If you exchange partner, you'll get what? Sodium nitrate and magnesium carbonate, okay? Magnesium carbonate. Magnesium carbonate is a PPT. So this, you're going to see some white PPT, so this is not the answer. And zinc and copper 2 sulfate. So this, if you undergo reaction, you will form zinc sulfate plus copper. So you're seeing some reddish brown solid. So this is not the answer as well, because you're going to see something. So by elimination, the only answer makes sense is A, okay? The solution for option A will be still colorless, okay? There's no gas, there's no PPT, so answer will be A. Next one. Question 18. A source has the empirical formula of NH4 2 Fe, then SO4 2, then 12 H2O. So this is actually the water of crystallization. So basically, this compound or this crystal is hydrated, okay? Water of crystallization. In the experiment, excess, so take note is excess. Sodium hydroxide is added slowly and then with shaking, and let it stand until no further change, okay? So it's left to stand. So whenever you see when it's left to stand, most likely it's undergoing oxidation. So whichever the solid or the solution will be oxidized, okay? So take note of this. So this one most likely is under QA and redox. Alright, so which of the following observation will not be made? Okay, will not be made. So there's iron and sodium hydroxide. So let me write somewhere here. So you're going to see iron hydroxide, which is green PPT. And so green PPT will be observed, that is true. A pungent gas which is produced will turn red limit, so as ammonia is produced. Is it true? Yes, because there's ammonium ions, okay? So ammonium ions plus NaOH, it will give you ammonia gas. Alright, so you'll produce ammonia gas. So this is true as well. On standing, a brown precipitate is produced. That is true. Why? Because your iron 2 hydroxide will undergo oxidation to form iron 3 hydroxide, okay, which is a reddish brown solid, okay? So this is true as well. The PPT dissolved in excess NaOH, okay? This is not true because your iron 2 hydroxide is insoluble in excess, so this is false. So which one will not be made? So answer is D, okay? Question 19. Both aqueous sodium carbonate and sodium hydroxide is added, which will turn solution red litmus paper blue. So most likely alkaline solution is being produced. Both solutions sodium carbonate turn red litmus paper blue. Okay. Which of the following substance can be used to differentiate the two solutions? So this should be under maybe salts and QA, yeah. Okay, so you're looking for a different observation between sodium carbonate and sodium hydroxide. So the different thing is the anion. One is a carbonate, one is a hydroxide. Okay, so this is the first one, this is the second one. So let's see, by elimination, you're looking for a different observation. So the only one that makes sense, I think, will be D. Okay, because when acid add into sodium carbonate, right, you'll see CO2 gas, so you see bubbles. Okay, but if HCl react with sodium hydroxide, it's just a neutralization. You just form salt and water. salt. Okay, so the observation will be definitely different, so answer should be D. Okay, C doesn't make sense at all. B, I don't think you'll see anything. There's no PPT, no gas, anything changing. And then calcium nitrate. For A, both you will get white PPT in both compound. Okay, so for this one you'll get calcium carbonate, which is a white PPT, and then for the second one you'll get calcium hydroxide, which is a white PPT as well. Okay, so but since they are the same observation, that's not answer. So the only answer is D. You want a different observation, Question 20. In which reaction is the underlying substance behaving as a OA, oxidizing agent? So this is definitely under redox. Okay, so take note, oxidizing agent, the substance itself, right, will undergo what? Reduction. So the best way to do this is to use oxidation number. Okay, oxidation number. So let's look at this. Chlorine is 0. So when it becomes this is -1. So from 0 -1 is being reduced. Next one, HCl is -1 to Cl is still -1. Any Cl, the oxidation number is still -1. So this one there's no change. Okay, no change. For this one, chlorine is -1. Then it become here is still -1. Okay, so -1 to -1, there's no change again. Okay, triangle means change, means no change. Okay, NaOH. Okay, so NaOH, this +1, oxygen is -2, hydrogen is +1 in this case. When you get this, I don't think there's anything going on. Sodium is still +1, chlorine is -1. Alright, so this one there's no change as well. Okay, so the only one that makes sense is you're looking for a reduction. Okay, so A is the answer. Alright. Question 21. So this one definitely is a I think it's a mole and QA. Alright, so first thing first, 10 cm³ and 1 mole per dm³ of iron 2 sulfate. So this is for iron 2 sulfate. So there's 10 cm³ and concentration is 1 mole per dm³. Okay, and you react with sodium hydroxide, okay, which is also 10 cm³. Concentration is 1 mole per dm³ as well. So this one is actually it's a limiting reactant. Okay, one of them will be one of the reactants will be in excess. So you need to figure out, because they ask you what did the reaction flask contains when the reaction is completed. Okay, so first thing first, you see the solid, right? Green PPT. So this is a green PPT. So definitely there's a green PPT, green PPT, green PPT. So C is out. Okay, it's not white, it's green. Okay, then next is you need to figure out which one is in excess. Okay, so we're going to do our mole concept. So do mole of FeSO4 equals to CV, concentration times volume. So it's 1 times 10/1000. So take note, change to dm³. Alright, so this you get 0.01 mole. You do the same thing. Mole of sodium hydroxide, CV. So it's the same working as well. Okay, both is 0.01 mole. Then next step, I just squeeze in at the top here the working. You do the mole ratio. So it's FeSO4 dot dot NaOH. This 1:2. So if iron 2 sulfate just now we have is 0.01 mole. So NaOH will be what? 0.02 mole, which is what we need. Okay, but in reality, we only add in 0.01 mole. So this is not enough. So in other words means what? Okay, your iron 2 sulfate is actually in excess. So it means at the end you still have a lot of iron 2 sulfate, which is a green solution. This is a green solution. Okay, so the final answer, green solution. So the only answer that makes sense will be D. Okay, so you see some green precipitate in a green solution. Okay, green solution because of the iron 2 sulfate, which is in excess. Question 22. Which substance does the sulfur atoms have the same oxidation number as the sulfur atoms in SO2? Alright, so oxygen is -2 times 2 become -4. So sulfur in this case will be +4. So this is a redox, this question, redox. So you are looking for +4. Whichever gives you +4, that's the answer. So let's start with this one. Oxygen is, let me zoom in a bit. Oxygen is -2. Okay, hydrogen is +1. So there's 2 of it, so it's +2. Okay, then this is -8. So sulfur should be +6 to balance out everything. Okay, so this is +6. Okay, this is just for your working. Next, so that's not an answer. We are looking for +4. So this one is +1. Oxygen is -2, so it's +2. This is -6. So to balance out everything must become 0. Your sulfur will be +4. So that's the answer. Okay, B is the answer. Let's try C and D in case some of you chose C or D. Sodium is +1, but there's 2 of it, so it's +2. To balance out, sulfur must be -2. Okay. Next, sulfur is sodium is +1, so there's +2 here. Oxygen is -2, so it's -6. To balance out, you need a +4, but there's 2 sulfur, so each sulfur will be +2. Okay. So +2 is not an answer. Neither is -2. So answer is B for question 22. Question 23. Okay, electrolysis. Yeah, so definitely is your electrolysis question. Okay, so chromium is deposited on the cathode when 0.08 mole of electrons is passed through a molten electrolyte. So this is the equation. Okay, so to solve this, you have to write the equation. Okay, so Cr is n plus n electrons to give you chromium in the end. Okay, and important, the mole ratio 0.02 mole, and electrons will be 0.08 mole. So the ratio is 1:4. Alright, so we can change this to 4 electron. Okay, so this means chromium in this case will be a Cr is 4 plus. Okay, we are looking for chromium which is Cr is 4 plus. So now we go back to look at the option. Which substance could be the electrolyte? Okay, so if you reverse cross for option A, so Cr will be 2 plus. Okay, not the answer. This is Cr is 4 plus. That's the answer. Then this one, if you reverse cross, is 3 plus. This one, if you reverse cross, is 2 plus. So answer is B. Okay, so a bit of electrolysis and chemical formula. All right. Question 24. So this is under fuel cell. Alright, a hydrogen oxygen fuel cell require a continuous input of fuel and oxygen. Fuel most likely is wrong. It should be hydrogen gas and oxygen gas. Alright, so it's wrong. Next, statement 2. Hydrogen and oxygen fuel cell. Hydrogen is burned in oxygen to produce electricity. They don't burn, they actually undergo a chemical reaction. So most likely it's wrong. Statement 3. When a hydrogen oxygen fuel cell is operating, water is the only product. Okay, so this makes sense. Okay, so which statement are correct? So since there is no option 3, I think most likely I will be more leaning towards 1 and 3. Okay, so this one I'll change it. Okay, sometimes you might get options they are quite similar. Okay, so then you have to go back and check again. So in this case, the fuel, basically I think they are referring back to hydrogen gas. So the best answer here, I think I would choose C. Okay, 2 definitely is wrong. They don't burn at all. Okay, it's just a chemical reaction. There's no fire involved at all. So answer is C. Okay. Question 25. Potassium, rubidium, and sodium are group 1. So this one definitely is your periodic table. And then it's your alkali metals, group 1. Okay, so they are all group 1. Which of them are correct? Okay, rubidium is the strongest reducing agent. So reducing agent, they themselves want to oxidize. Okay, in other words means he's actually the most reactive. They are saying that it's the most reactive. Okay, because rubidium really want to become Rb plus. Okay, so they themselves oxidize in the process, but they reduce the other reactant. So is it true? Yes. Okay, the lower the element, the lower the metal in group 1, the most reactive it is. So it's true. Okay, so statement is true. Sodium loses its valence electron most easily. No. Okay, he's not the most reactive. Rubidium, it should be rubidium. So this out. Rubidium has a greatest tendency to form negative ions than potassium. No, it's not negative ions. It should be positive ions. So C is out. So the reaction between sodium and water is the most violent. It's not the most violent. It should be rubidium. Rubidium then is the most violent. Okay, not sodium. So it's out. So answer is A. Question 26. Limestone contains impurities. Okay, limestone. Which the diagram shows the change in mass. Okay, change in mass when pure calcium carbonate is heated. All right. So which graph shows a sample of limestone again containing impurities that are the most stable to decomposition? So meaning the impurities inside limestone does not undergo decomposition. So if you write your equation, let me scroll down here. Calcium carbonate, okay, CaCO3. When it's been heated, it will form calcium oxide plus CO2. Okay, so they will actually give out CO2 gas. So it will get lighter and lighter. So you will get lighter as you heat it. Alright, so get lighter. Okay, so but something to take note is it will decrease. So C definitely is out. Okay, but how it decrease? Okay, so this one if you calculate the MR is actually 100. Okay, if you use a periodic table, MR this one is 40 plus 16 is 56. So he will drop by about 44%. Okay, so he wouldn't really drop that much. So B is out. A does not decompose at all, which is not true. You will undergo decomposition, so you get lighter and lighter. Okay, so by elimination, B will be the most likely answer. Okay. Question 27. The reaction of a metal oxide with hydrogen. So this is under a reactivity series, your metal. Alright. So which of the following is correct? So important thing is what metal oxide with hydrogen and you have a ongoing flame going on. Okay, so meaning this metal itself, right, it has to be lower than hydrogen in the reactivity series. So if you remember your reactivity series, whichever is lower than hydrogen will be example like your copper, okay, your lead, or this, okay, silver, gold. Okay, so and for example, if I give you copper oxide, okay, plus hydrogen gas, the equation, so you get reduced, so you'll form copper plus water vapor. Okay, so basically it's from copper oxide to become copper, so it will get lighter. So the mass of metal oxide after heating, right, it should decrease. Okay, so and also it must be lower than hydrogen in the reactivity series. Okay, so the most likely answer will be B. Okay, question 28. So this is under exo endo energy changes. Okay, next one. So it's a negative, so enthalpy is negative means it's an exothermic reaction. They give you the bond energy, hydrogen is 436, Cl is 244. So what's the bond energy of a HCl bond? So first you have to calculate energy absorbed. Okay, okay, energy absorbed is to break your HH bond. So H bond, one of it, and Cl bond. Okay, so HH bond is plus, you add in absorb 436 and you absorb 244. So if you use in our calculator, it will give you 680. Next, energy release. So when you form the bonds, you will release the energy. So you'll form HCl Cl, HCl. Take note, there's two of it. So okay, so we are looking for HCl, so you can let it be 2x. Okay, so enthalpy change is minus 92 equals to plus 680 plus negative 2x. Okay, so this minus because it's release, so it's minus. So if you rearrange like Emacs, 2x equals to 680 plus 92. So x will be 386. Okay, so if you press your calculator carefully, you should get 386. So answer will be B. Moving on. 29. Which one has increased the speed of reaction between 1 mole of 2 reacting gases? So this is under rate of reaction. So in the decrease in temperature, okay, you slow it down, so it's out. Decrease in the volume. So if you decrease in the volume, so basically they are more compact, so the pressure is higher. The speed will be faster. Okay, so this one seems true. A decrease in the surface area of the catalyst. Decrease is not correct, it should be increase, provided they even use a catalyst. Okay, for D, an increase in the volume. So if you increase in volume, the pressure will actually drops. Okay, then your rate will actually decrease as well, so it's not true, so answer should be B. Next one, question 30. So this is definitely energy change. Energy changes. So the energy, this is an energy level diagram. So the reactants drop to products. So this is actually a exothermic reaction. Okay, so which reaction would be appropriate for this? Okay, so you're looking for exothermic reaction. All right. So CH4 is methane. Methane react with oxygen is combustion. Combustion is exo. Is true. Is exo. Glucose plus oxygen gas. So this is your respiration. It will be exo as well. Okay, keep the animals or human warm. And carbon react oxygen gives you CO. So combustion, although it's like a incomplete combustion, but it's still exo as long as it's burning. So all three are correct. So answer is D. Next one. 31. So this one should be under rate of reaction. So the first reaction, 10 grams of magnesium, so take note it's 10 grams, and then react with 0.5 dm cube of 2 mole per dm cube of HCl. The other one is also magnesium, but it's the first one is ribbon, but this is powder, and this is using 5 grams. So it's 0.5 mole per dm cube, 0.5 dm cube and 3 mole per dm cube of HCl. So the volume is the same, but the concentration is different. Okay, the concentration is different. This one, and then this one, the mass is different as well, and then the surface areas are different as well. Only the volume is the same. Okay, so I ask you which of the graph is correct. So first thing first, you have to calculate the mole of magnesium and hydrochloric acid. So this one, the working is going to be pretty long. So mole of magnesium, mass over AR, so be 10 over 24. Okay. Next, so for this one, mole of magnesium, 5 over 24. So 0.21 mole. Next, you need to find the mole of HCl. concentration times volume. So it's 2 times 0.5, which is 1 mole. Okay, and this one, if you times together, is CV as well. So it's 3 times 0.5, 1.5 mole. Okay, so just to play safe, you have to write a balance equation. Okay, so I'll just squeeze it at the bottom here. Magnesium plus HCl, if you balance your equation. So just take note, the mole ratio is 1:2. So if you look at reaction 1 first, okay, so you have more mole. Let me use a different color. 0.42 compared to 1 mole. Okay, so in this case you will have excess acid. So your magnesium will be your limiting reactant. Okay, then what about reaction 2? Reaction 2, you have 0.21 mole compared to 1.5 mole. Okay, so in reaction 2, your acid will also be in excess. Alright, then now come to the next part of rate of reaction. So for rate of reaction for this kind of graph question, right, so you must know there are two things. So first one, you must know the gradient of your graph. Second one is the endpoint, meaning the final volume of the gas produced. Okay, so you look at reaction 1 and 2, right? Which one will have a higher gradient, which depends on concentration in this case. Okay, so if you see carefully, this is 2 mole per ln cube, this is 3 mole per ln cube. So reaction 2 must have a steeper gradient. Okay, this is out, this is out. This one is possible and this one is possible. Okay, then next, coming back, let's look at the endpoint. Okay, which one give you the more products in the end? So for reaction 2, this is the limiting reactant. For reaction 2 is 0.21 mole, but for reaction 1, the limiting reactant is 0.42 mole. So means reaction 1 will give you more volume in the end, okay, of hydrogen gas. So it must be higher. This they are the same endpoint is not correct. Okay, so this one gives more volume is correct, but because this one the gradient is more gentle, is out already. So the only answer that makes sense will be C. Okay, C will be the final answer. Okay, so take note for this one, rate of reaction. Okay, the gradient depends on the concentration or mass. Okay, but in this case the endpoint, right, depends on your limiting reactant, the mole of limiting reactant, which is in this case is magnesium. So take note. Okay, moving on. 32. Powdered manganese oxide is a catalyst for your hydrogen peroxide. Okay, so if you want the equation, this is the equation, H2O2. It will just decompose, it won't react with anything else. It will give you water plus oxygen gas, and the ratio is 2:1. Okay, so you produce water and oxygen gas in the end. So which statement explains why the rate of production of oxygen decreases during the reaction? So it will decrease because what? Less and less reactants. Less reactants as the reaction proceeds on. Okay, less reactants. So yeah, the only one that makes sense is this one. Okay, so because the reactants is hydrogen peroxide, so only this makes sense. Manganese oxide, the mass does not decrease. The catalyst, the mass does not decrease. Okay, so B is out. The surface of manganese oxide decreases. That is not true. Actually, it's question mark. We will know. Most likely it's not true. Temperature decreases. No, that's not true as well. So answer is A. Okay, so this is under rate of reaction as well. Answer is A. Question 33. So start with your organic chem. So this is under alcohol. So which of the statement is correct? So you have 4 different alcohol in this case. So alcohol 1 can be made by addition of steam to an alkene. Is it true? No. If you still remember alkene, the general formula is what? CnH2n. and it starts from n equals to 2, 3, and so on and so forth. Okay, so the smallest is C2H4, but this is only what, one carbon. Okay, so statement 1 is definitely wrong. Okay, you need at least 2 carbon to be considered alkene, and you need a CC double bond, of course. Alcohol 2 is a product of fermentation, so this one is 2 carbon, so it's ethanol. So it's possible, it's true, yeah. Fermentation will produce ethanol. Okay, alcohol 3 can undergo oxidation to form H3H7COOH. Okay, so let's take a look. 3 carbon, C3, and then H7OH. Okay, so if he undergo oxidation, so he will become from ethanol, from propanol, to become propanoic acid. Okay, so it's true, you undergo oxidation, is true, C3H7, but what is not true is what? If you see carefully, he has 4 carbon, okay, but alcohol 3 only had 3 carbon, so there's no way he can increase 1 more carbon from 3 carbon to 4 carbon, so it's not true as well. So don't get tricked by the carbon. So take note, a lot of students will make this mistake. There's a carbon hiding in the functional group of carboxylic acid, COOH. Okay, so total there are 4 carbon. Next one, alcohol 4 has only one other isomers. This one is not true, because depending on where you place your OH, right, you'll get different isomers. Okay, they say only one. It's not true. I just show you an example. Another isomer for alcohol 4 is actually this one. Carbon, 4 carbon, and each carbon 4 bonds. And then this OH, right, I can put it under here. Okay, so this is one isomers. This is considered another isomers. Okay, so it's totally different. So they say only one is not true. So this is how. So only answer that makes sense is B. Alright. 34. So this is under organic chem again. So why do these compounds all belongs to the same homologous series? So basically it's the same family. So either you are alkene or alkene, okay, or alcohol and carboxylic acid. So one look you can tell they all have a CC double bond. So this definitely belongs to the alkene family. Okay, CnH2n, the alkenes family. E. So coming back, so they are all saturated. No, they are unsaturated because of the CC double bond. So it's not true. So they are all hydrocarbon, yes, because they only contains carbon or hydrogen. Okay, you cannot have any other third element involved. Okay, they all contain the same functional group. Yes, they all contain CC double bond. Okay, they all contains an even number of carbon atoms. Not true. Let me see. This has 2 carbon. This has 4 carbon. This has 6 carbon. Might be true. Let me see. Okay, B, C, D are all true, but coming back to the question, why they all belongs to the same homologous series? So under the properties of homologous series, right, they must have the same functional group. So out of B, C, D, although these 3 statements are true, but C is the most important statement. It's one of the property to define whether a compound they belong to the same homologous series. They must have the same functional group, okay, and same general formula as well, okay, which is CnH2n. Okay, B and D, although it's true, they are not really that relevant, not really that crucial. Okay, so C is the answer. 35. So you have compound Z, which prediction is likely about its property is not likely to be correct. So you're looking for which one is wrong. Okay, so take a look. This has a COOH, it's a carboxylic acid. It has a CC double bond, and then you have OH, which is alcohol. Then this is a alkene, and this is a carboxylic acid. Okay, so let's look at option A. It can react with zinc to give out hydrogen gas. That is true. Okay, because of the acid, carboxylic acid. Okay, so it's like a weak acid. You can still react with your metal to give you hydrogen gas. So it's true. It can turn acidified potassium iodide, okay, which is your famous Ra reducing agent, from colorless to brown. Okay, so is it true? No, the closest is actually alcohol. Alcohol can react with a OA, okay, to form a carboxylic acid. Okay, to give a carboxylic acid. So does not really react with a reducing agent. So this one I'll put as false. Addition polymerization, yes, because it has the CC double bond. Okay, so you can open up the CC double bond. So it's true. It only works for alkene or any compound that has CC double bond. Condensation polymerization by itself is true also, because it has your alcohol, the OH group, and your carboxylic acid. Okay, so together they will form the ester linkage, which is possible. So only B is false. 36. Hydrogen is used as a reactant in both in Haber process and the addition of alkenes. Yes, hydrogenation. All right, so this one. Hydrogenation is to produce your margarine. Okay, then your Haber process is to produce your ammonia. Yes. Okay, so which rule is correct? So in Haber process, it's used iron as the catalyst. In addition, product of addition of hydrogen to alkene, in the end you will form alkene, because as after you open up your CC double bond, okay, so when you add in your hydrogen gas, so you remove this and open up your double bond, so you plug in hydrogen and hydrogen, so you become a alkane now. So the only one that makes sense is B. Okay, moving on. Okay, question 37. So is in introduction to organic chem. So which property does the fractions at the top have as compared to the bottom one, the bottom fractions? Okay, so the fractions at the top, they have a lower boiling point and lower viscosity. Okay, and then let's look at option. Higher viscosity, that's wrong. Lower boiling point is correct. Lower volatility is wrong. Okay, they have a high volatility, basically means they can change state easily because they are all gaseous state, because they have a shorter carbon chain. Okay, so they are all gases. So only 2 and 4 are correct, so answer is C. Okay, question 35 is organic chem as well. So which statement about organic chem is correct? Okay, each molecule of proper 1 nor has 1 OH group, and each molecule of proper 2 nor has 2 OH group. Oh, that is wrong. Okay, the 1 and the 2 basically just tell us where is the OH connected to which carbon. So proper 1 nor, if you see carefully, is 3 carbon. Proper nor, pro means 3 carbon, is connected to the first carbon. This is the first carbon, second carbon, third carbon. Okay, but proper 2 nor, right, is this is how it looks like, 3 carbon, but it's connected to the second carbon. Okay, so this is the first carbon, this is the second carbon, this is the third carbon. Okay, so these two, this is how it looks like. So if they say it has 2 OH group, it's not correct. Okay, it still has 1 OH group, it's just that connected to the second carbon. Option B, octane and decane. Octane is 8 carbon and decane is 10 carbon. They are in a homologous series with the general formula of CnH2n is false, because they are all alkanes. Alkanes is Cn H2n plus 2. Okay, C, the ester butyl butanoate has 8 carbon atoms. Bu is 4, there's 4 here, there's 4 here, total is 8. Is true. Okay, 8 is true. Alright, so let's look at option D. The structure of the functional group of a carboxylic acid is COH. It looks correct, but actually it's not. Because for carboxylic acid, the functional group is actually, there's a double bond O. O, then H. That is the correct one. So answer will be C. Question 39. A chlorine atom can replace a hydrogen atom in a molecule of butane. Okay, this is butane to form chlorobutane. So this is a substitution reaction for alkenes with UV light. Okay, so how many different structural isomers can butane be formed? So basically, you are playing around with the chlorine. Okay, so depending on where you place the chlorine, you'll get a different isomers. So how you should do it? Let me scroll up. You get this 4 carbon. So the first one you can put it at last carbon. The other one you can put in the second carbon. Some students might say connect to this one, but this second, this is the first, second, third. Second and third, they are actually the same, because if the third one, if you flip it, right, you're same as number 2. Okay, so this is not correct. So 3 is not correct. Let's try one more. So single chain, you have run out of options. So let's say if you do a branch chain, okay, and then now you connect to the first carbon. Okay, then number 4, same branch chain, but now you connect to the second carbon. Okay, so I think these are the 4 different isomers. So this one is a little bit more tricky. You have to draw out the main structural formula. Okay, so usually we don't draw the hydrogen because important is the carbon chain and the location of the chlorine. Okay, so answer is D. Question 40. Which of the following is correct? Okay, different strategies to reduce effects of environmental issues. Okay, so strategy to reduce the effects of climate change. So let's see which one makes sense. Strategy to reduce the effect of acid rain. So as to reduce acid rain, you need to reduce NO2 and SO2. Okay, so using low sulfur fuel, that makes sense. If you plant more trees, basically it's just affecting the CO2, okay, which is not useful for reducing acid rain. Climate change usually is talking about global warming, CO2. So you need to reduce the amount of CO2 being produced. So reduce in the use of renewable energy. No, that is the good thing. So reduce in livestock farming, that is true. So answer should be B. Okay, that's all. Like, share, subscribe.